Welcome back. We have a problem here and it reads, a uniform meter rod of length AD and weight 84 newtons is supported at 2 points B and C such that AB is 20 centimeters and CD is 10 centimeters. Two forces, 42 newtons and 35 newtons, are placed at A and D, respectively. If the system remains in equilibrium under the action of these forces, calculate the reactions at B and C. So the question is asking us to calculate the reactions at B and C. Before we can be able to find solutions, the first thing we will be able to do is to draw a diagram. We are going to use the information given and draw a diagram. So this is the rod, and one of the informations that we have from the question is it is a uniform meter rod. A meter rod means that the total length of the rod is 1 meter, so which means is 100 centimeters. And uniform means that the center of gravity of the rod is exactly at midpoint. So this means that the weight of the rod will be exactly at the center or the middle of the rod. So it's going to be at 0.50 centimeters. Okay? So whenever you see the word uniform, it means that the center of gravity of that object is exactly at the middle. Okay? And from here, we know that it is 100 centimeters in total length because it is a meter rod. Now, the first information, let me try to represent that on the diagram. Since it is uniform, it means that its weight has to be exactly at the center. So if this is the rod, then let's say this will be the weight. Okay? So the weight of the rod is 84 newtons. 84 newtons. We've said that since it is a uniform rod, the weight has to lie exactly at the center. And the length of the rod is AD, which means 100 centimeters. So this means that distance from A to the center will be 50 centimeters. And the distance from here, the center, to the other side will be 50 centimeters as well. Okay. In the question, two supports were placed and they are B and C, such that they are placed in the distance AB is 20 centimeters and CD is 10 centimeters. Let's try to represent this. All right. So let's say we have the support or the pivot for B here. Okay. This is B. And let's say we have for that of C here. Okay. So we know that the distance from A to B is given in the question as 20 centimeters. That is 20 centimeters. Okay. And the distance from C to D is given as 10 centimeters in the question. So 10 centimeters. And at point A, if we go back to the question, 42 Newton force is suspended at A and the 35 Newton force is suspended at D. Okay, that's why it says respectively. Let's try to represent that information on the diagram. So at A, the 42 Newton force is suspended, and at D, the 35 Newton force is suspended. The question is asking us to find the reactions at B and C. So those are the upward forces, right? Let's call the reaction at B R1 and the reaction at C as R2. Okay, so to complete this diagram, if this is the center of the rod, which is 100 centimeters, then it means from here to the end, this point A will be 50 centimeters in total. So if the distance from here to here is 20, what will be the distance from this point to here? It will be 30 centimeters, obviously. We agree to that? Yes. Again, if from the center here to this point is 50 centimeters, and this point C to D is already 10 centimeters, it means that from here to this point will be 40 centimeters. Yeah. So, and this is the completion of the diagram. Now we can move on with the calculation. Okay, we need to find the reactions at B and C, which we call R1 and R2. So let the reactions at B and C be R1 and R2 respectively. Then we know that the total sum of the upward forces is equal to the total sum of the downward forces. This is one of the principles of moment. So the total sum of the upward forces will be R1 plus R2 is equal to total sum of the downward forces are 42 newtons plus 84 newtons plus 35 newtons. So that will be R1 plus R2 is equal to 161 newtons. So the other principle of moment states that the total sum of the clockwise moments is equal to the total sum of the anti-clockwise moments. Okay, so we need to take moment at a point. So let's say taking moments from B. You can take it from C if you like. It doesn't matter. So going back to the diagram, if we should take moments from B here, that is going to be our reference point. Okay, so it means that we are assuming that C is not in existence. So with that, let's try to identify our clockwise and our anti-clockwise moments. For the 84 Newton force, this is how it will act towards that pivot. So it is moving in the same direction as that of the hands of the clock. So that's why it will be clockwise. And for the 35 Newtons, is also going to act this way towards the pivot. So it is also clockwise moment. For the 42 Newtons, it is moving anti-clockwise. Okay. For the R2 is also moving anti-clockwise. Okay. If we are taking moment from any pivot, so it means that the moment of that will be 0. So R1, the moment will be 0. Okay. Because the distance is 0. All right. Being able to identify the forces into clockwise and anti-clockwise is very important. Otherwise, there is no possible way of getting the correct answers. All right. The clockwise moments is equal to the anti-clockwise moments. That is important to note. Okay. We are taking moments from B. So moving on, if we are taking moments from B, for the 84 Newton force, the moment will be the force multiplied by the perpendicular distance from that reference point. So it will be 84 multiplied by 30 plus the other clockwise moment is the 35 Newtons. So that will be 35 Newtons multiplied by the total distance or the perpendicular distance from the reference point B. That will be 30 plus 40 plus 10. Okay, so that will be 30 plus 40 plus 10. Okay, this is equal to the anti-clockwise moments. For the anti-clockwise moment, we have the R2 force that is acting at a distance of 30 plus 40 centimeters if B is the reference point. So that will be R2 multiplied by 30 plus 40 plus the other anti-clockwise moment is the 42 Newtons, and the distance from the reference point is just 20 centimeters. So that will be 42 times 20 centimeters. Okay, I know you will be wondering why I did not convert the distances to meters. It doesn't matter. If you like, you can do it that way. You will have the same answer. So that should not be a concern. Okay? All right. So moving on, 84 times 30 is 2520 plus 35 multiplied by 30 plus 40 plus 10 in brackets will give you 2800. This is equal to 30 plus 40 is 70. So multiplied by R2 will be 70 R2 plus 42 times 20 gives 840. If I should add 2520 to 2800, that gives 5320 is equal to 70 R2 plus 840. Collecting like terms will be 5320 minus 840 is equal to 70 R2. So 5320 minus 840 gives 4480 is equal to 70 R2. To find R2, I divide both sides by 70, and R2 is equal to 64 newtons. But remember, we've said R1 plus R2 is equal to 161 newtons. So R1 plus 64 newtons is equal to 161 newtons. In that case, R1 is equal to 161 newtons minus 64 newtons. R1 is therefore equals to 97 newtons. And that answers the question. Thank you very much for watching this video. If this is the first time of visiting our channel, please like, subscribe, and share the video. You can also follow our Facebook page so that whenever a new video is uploaded, you can be able to watch it earlier. Thank you very much.